Hi guys, I'm Adam, and today I'll be talking about the intuition behind total product, average product, and marginal product, together with how do we actually interpret those curves on a diagram. So before diving into all these details, I will probably remind you of a couple of concepts. So in the short run, at least one factors of production is fixed. In the long run, all factors of production are variable. So for the simplicity of analysis, usually what we do in those introductory microeconomic courses, we usually just consider capital and labor for the simplicity of analyzing the diagrams, two inputs. So over here, we are considering labor as a variable input. Let's dive straight into the diagram over here. So the bloom line here actually illustrates the total product curve at each and every individual input. So, well, let's look at the average product. How do we actually know the average product and plot the curve on below just by using the data from this blue curve? Well, we can actually find the average product just by connecting the origin to any single point on the total product curve, and then we calculate the slope of this, and that will give us an average product. For instance, if we consider point A, and let me drag it down here, we just calculate the slope of this black line, and that will give us the average product. It's basically, as I have said here, it's a y-intercept divided by the x-intercept of the first diagram. That's all we have to do. And let me give you a bit of intuition behind why that is true, and how do we find the maximum average product. So let's say we start at a random line going through the origin, because we have to include all quantities of inputs. So we will be starting at the origin, because average product basically divides every single input that's put into the production. So we will have to start from zero. We will have to divide through all the inputs we have. So it will be a straight line going through the origin. So let me get rid of this, and let's see. So if I start off with this random straight line going through the origin, and then I wanted to find how I can get the line that shows me the highest average product. Well, I can just rotate inwards. Rotate, rotate, rotate until I hit the total product curve, which is exactly at point B, where I actually hit the total product curve. So that's when the slope of this straight line will be the highest, meaning that the average product will be the highest as well. So you can see that when I trace it down, you can see that's exactly the point B, which is the highest point on the average product curve. Okay, so I have finished illustrating the average product, then we dive straight into the marginal product. It's actually easier to understand the concept of marginal product, because the marginal product basically illustrates an incremental change of the productivity if I increase the inputs by 1 unit. So that's essentially the slope of the total product curve. So we just see where the slope of the total product curve will be the highest. So we trace it on this line increasing, increasing, and then the slope will decreasing. So we know that the slope of this product curve, total product curve, will have the highest slope at the point A. So just to illustrate that, we can put a purple line over here illustrating that these tangent curves will have the biggest slope when it actually intersects point A. So that's basically the highest point of marginal product, which if we trace it down here, it's exactly the point A, which is the highest point of the marginal product. And finally, we will be looking at the point C, which is the highest point on the total product curve. That makes a lot of sense because when the total output begins to decrease, that means that any additional worker that we put in place will actually decrease our total output, meaning that the marginal output or marginal product is negative. So this negative portion corresponds to the negative portion up here. So these two can actually give you a great intuition of why they are actually decreasing together, because any additional worker will not increase the output but to decrease the output, meaning that a lower incremental change in output, a negative incremental change in output. If you like this video, please hit subscribe. There are a lot of awesome videos in my channel, and we'll be continually uploading these videos onto my YouTube channel. Thank you so much.